The topic of this lecture is heat equation. We'll cover heat equation in this lecture. So let us see the problem. Find the solution of heat equation using separation of variable method. For this, consider one-dimensional heat equation which is given by this. Now let take xt is equal to xx into yt be a solution of differential equation. That is, we are supposing that for this differential equation, the solution is of this form. Now using equation number 2, we obtain from equation number 1. That is putting these values t, xt, that is xx and yt over here, and putting these values over here, we'll obtain these two values. How we get these values? So simply just see the first expression. This will become, in this case, del by del t, and this becomes xx into yt. And because we'll have to find the partial derivative with respect to t, so this will come as a constant outside, and this becomes y dash t. So this is the value we have obtained over here. Similarly, from this we can easily get this one. Now this equation can be written like this, and we'll write lambda, which is called the separation constant. Now from here, taking equation number 1 and the last, and the equation number 2 and the last, we get these two equations. Now when we solve this equation number 4 and 5, we have given the name. Three distinct cases arises. So what are these cases? Let us say case number 1, when lambda is positive. This lambda is positive. Say it is equal to alpha square. Then the solution in this case, the first equation solution will be this, and the second equation solution will be this. How will obtain this solution? Let us see for the first equation. In this case, the auxiliary equation will become m square minus lambda is alpha square. So it is alpha square is equal to 0. From this we get m is equal to plus minus alpha, and from this we know the solution is of this form. In case of the second equation, this is simply dy by dt. So this becomes dy by dt is equal to k times alpha square y. So this y will go down. So dy by y is equal to k alpha square into dt, and taking the integration, we get the log y is equal to k alpha square t plus some constant, say c3 dash. C3 dash, let us suppose this. And taking the exponential of both sides, we get y is equal to e to the power k alpha square t, and this, because of this, it becomes a constant, so we say it is constant c3. So this expression will get, and this is written over here. So we get the value of x and y in this case. Now let us see the case number 2, when lambda is equal to minus alpha square, where alpha is positive. The solution will be of the form, this will be the form in this case. Again, how we find this? So this is the equation. Here in this case, this becomes, in case number 1, it becomes m square, and this lambda is minus alpha square in this case. So it becomes alpha square is equal to 0. So this gives the value m is equal to plus minus alpha I. And in case of second, just changing this value minus, it will become plus. So second equation will be dy by dt, and this become plus k times alpha square y is equal to 0. And solution will be similar to this. Some changes will be there, little change will be there. In this case, the solution we know. What is the solution in this case? In this case, solution we know of this form. and the second case will be this. So these are the value of x and y in this case. Now in case, let us say case number third, when lambda is equal to 0. When lambda is equal to 0, in this case simply the first equation will become del 2x by del x square is equal to 0, and the second equation will be dy by dt is equal to 0. So from this two equation we can easily find that the solution is x is equal to, because from the first its equation is del 2x by del x square is equal to 0. So this gives del x by del x is equal to c1, and from this finding one more time derivative we get x is equal to c1x plus c2 and y is equal to c3. This simple is the second equation gives c3, and thus the various possible solutions of one dimensional heat equation will be txt is equal to, this is of the first case, this is of the second case, and this is of the third case, where a is equal to c1 c3 and b is equal to c2 c3. So all these cases, in all these cases, these will be the solutions. So thank you very much. You can find the link of this lecture in description box. PPT.